So there are some underlying assumptions for the t-test, and those assumptions are the following. So the assumption is that the samples that we're taking are random samples from the population. The other assumption is that those populations are normally distributed. And the other assumption is that the standard deviation and the variance of the two populations that we're sampling from in a two-sample t-test is that the variances are equal in those two populations. This turns out to be rarely the case, and so typically we apply a correction that accounts for these deviations from the assumptions. And this correction is called Welch's correction, and so we use Welch's t-test. And essentially what this allows us to do is that it's a slight modification to how the degrees of freedom and the standard error are computed. And I'll give you the formula here, which is simply that the degrees of freedom are computed as the variance divided by the sample size for each of the two values summed, and then they appear again in the denominator here. And so this correction is used, and I tell you this because this is what's used in R when R computes the t-test statistic for a two-sample t-test. And so you'll see that it's referred to in the output as Welch's t-test, and also that your degrees of freedom will differ from your expectation because it will be, you know, a number like 11.8, for example, because of this particular correction. And so you can change this output in R so that you don't use this correction, but this is the correction that's used by default.